Welcome back everyone to part 6, which is actually a continuation of part 5 because we didn't have time to finish the ranged enemy behavior. So in this part we're going to continue with the enemy movements, the ranged enemy attacks, taking damage and hiding to go heal, and after healing coming out and attacking us again. Alright, so let's get started. So now let's actually start editing our ranged behavior tree. So open up our AI folder, and in behavior trees, let's open up BT enemy ranged, and let's start doing something with our combat state. So at this point, you should start thinking how you want your enemy to behave, and this behavior is during combat. Now, the first thing that I want to do is, as soon as the enemy sees me, I want them to start moving around, to find a nice place to move and then attack, or start evading my attacks. So let's create a sequence node here. I'm going to call this, I don't know, evade and attack. And the first thing we want to do here is set focus, focus target, and we want to focus on the attack target. We want to set our movement speed to something like jogging. And then we want to actually run some EQS query and store it in the point of interest. Now, I'm not going to choose from one of the EQS queries we created because we're going to want to create a new one here. But just hold that thought for a second. After I run the EQS query and store the value in the point of interest, let me actually, instead of single best item, let's say get single item from best 25% to get a random position from the best 25%, and then call the move to and pass in the point of interest. After that, let's do a wait for something like 0.3 seconds with a random deviation of 0.1. And finally, let's call our attack function. All right, so on a high level, this is basically what the evade and attack is. We're going to be moving and then attacking and then repeating move, attack, move, attack. But there are a few things we need to do first. First thing is that we haven't changed the movement speed for our ranged enemy. Now, if you recall, let me go back to my ranged enemy. In our interface, we have this set movement speed. And if I don't change anything, then it's going to take the values that we have defined here in our base enemy. But I actually want the ranged enemy to have different speed than our melee or base enemy. So I'm going to go over here to my enemy ranged. I'm going to double click the set movement speed, and I'm going to change. So I copy everything from the base enemy, and I'm going to paste it here. And I'm going to change these values a bit. I'll plug in this one here. All right. So the walking speed is the only thing I'm going to change. I'm going to make this 200 for our ranged enemy, because I want them to have a slightly faster walking speed than our melee enemy. And also, one thing we want to change as well is get ideal range. So if you recall, this was the radius of attacking and defending. So for our base enemy or our melee enemy, this value was 150. So that means the enemy needs to be within 150 units or 1.5 meters of the player to attack, and needs to be within 350 units to defend or strafe. For our ranged enemy is going to be different. The ranged enemy can attack from a much further distance. So let's say the attack radius here is, I don't know, like 600. And I'll set the defend radius to the same, 600 as well. All right. So back to our behavior tree. The main thing we need to do now, well, of course, other than creating the attack event, is what EQS query we're going to run. So for our ranged enemy, I want the enemy to be moving at the maximum distance that they can from the player and just keep finding a random position around the player far enough so that it's hard for the player to hit them, but close enough so that they themselves can aim well. So let's create a new EQS query for that. So again, here in our AI folder, EQS, gonna right click, search for environment query, and I'm gonna call this one EQS underscore find ideal ranged location. Open this up, and we're gonna do something a bit different here, but first of all, let's generate a grid of points. So far what we've been doing is selecting the grid size manually here, so saying 500, 1000 and so on. And again, to show you how this looks like, or to remind you, select your EQS testing pawn, search here in the details panel for EQS, and choose the new environment query we just created. And again, remember, for testing, we had this EQS context attack target. We want to put it to be our player start location, because in the editor we don't have an attack target yet. So this is again just for testing. And what I want to do now is, in this EQS query, generate a grid around our attack targets. All right, just like this. But what I was mentioning is that right now I have the grid's half size to be 500, let's say space between to be 200, something like that. But what if, or maybe 150? Yeah, 150 is fine. Okay, fine, no, 200. Okay, 200, I changed my mind. All right, so what if I actually want this number 500, to be a variable? And let's say I want it to be whatever the attack radius is. So if my ranged enemy has an attack radius of 1000, I want this number to be 1000. Well, to make this number a variable, you can open this up here and you'll find something called data binding. Now under data binding, choose query params. If I select query params and then open it up again, I can give it a parameter name. So I'm going to say something like grid half size. All right. And now if I open up my behavior tree, put this back. If I open up my behavior tree and select the EQS query here that we just created, find ideal range location, under query config, you'll notice that we have an array now, and it has a parameter. It says parameter name grid half size. That's the parameter we just created. And now I can give it a default value here, or I can actually select a Blackboard key to fill in this value. So I'm going to select my attack radius. Nice. So now whatever the attack radius is will be the value of my grid size. Now you can't really see this in the editor, again, because this value hasn't been set. So for now, just for the editor, I'm gonna change this back to none and put a value of like 500 or 600, just so we can test it out. But I'm gonna return this back and show you how you can see it in during gameplay. All right, so let's think about this EQS. Where should the ranged enemy be while attacking the player? So first of all, as we did with all of our other EQS queries, I'm gonna open it up here. We need to add first a pathfinding test. So I'm gonna keep everything as default, so it discards any point that's not reachable. That's what pathfinding does. So now all these points are green, and if I move this back, you'll see that yeah, it discarded some points that, well, everything is reachable actually now. Yeah, it doesn't matter. If something's unreachable, it will discard it. And we want to do something else as well. We actually want to make sure that the ranged enemy can always see the player. So for example, if the player is standing somewhere here, and the enemy is standing somewhere here, this shouldn't be a valid location. And also, this shouldn't be a valid location, this shouldn't be a valid location. Anything behind this wall shouldn't be a valid location because the ranged enemy can't shoot the player from here. So let's add a test and call it look for trace. And we're going to do a trace. So our context here should be our attack target. And it's by default set to filter and score. I just want it to be filter only. So filter out anything that the enemy can't see the player. And bool match, we're going to untick this to switch the locations. Switch the condition. And if you read here, it says require no hit. If I turn bool match on, it will say require hit. Now, I require no hit. That means that a trace from the enemy to the player with no hit is the location that I can see the enemy from. So if I'm standing here, then I can actually see the player from here. But if I'm standing on one of these blue or filtered out points, then I obviously can't see the player. So this does what we want. Now let's add another test. So I want the enemy to always choose a point that's furthest away from the player or on the edges of this grid, so that they maintain the maximum distance that they can from the player, because of course they're a ranged enemy. So then I'm going to add a test. I'm going to add a distance test, and I'm going to say distance to the attack target. And I'm just going to score here. And I'm going to keep everything as is. So it says prefer greater. So the points that are further away from the player will have a higher score, regardless of where the enemy is. So if the enemy's here, it doesn't matter. These points depend on where the player is. All right. So there's one other thing we want to do. So if I'm standing here, I don't want to stay standing on the same point. And I don't want to move to the point closest to me. I want the enemy to actually move a nice amount of distance before attacking, so that it's actually evading from the player's attacks. So to do that, I'm going to add another test, also distance, but this time I'm going to say distance from querier. And it's going to be filter only, because I want to filter out values that are that have a minimum of, say, 200. Nice. So you can see now that it's filtered out these three. So it's never going to move to the point that it's currently on or the next two closest points. And if I increase this value a bit to, say, 300, then it's going to increase the distance, the minimum distance the enemy will move. So this means the enemy will move a minimum of more than 300. So I'm gonna keep it at that. All right, let's put this back here. Go back to our behavior tree. Oh, actually, one more thing. Since we're just testing with this grid half size as 600, don't forget to put back the data binding to be your query parameter. And then let's say, what do we call it? Grid half size. All right. So actually, let me show you what this looks like in game. I'm going to remove the attack because we don't have an attack right now. And I'm just going to show you the movement. So let's test this out. Oh, don't forget the attack target to put it back here. Remove what we did for testing. And the testing pawn, let's move it a bit back here. All right, so let's see what this looks like. If I play here, press the apostrophe key and 3 to bring up the EQS. So you can see that the EQS is generated around me in a 600 unit area. And the enemy is moving, choosing a point furthest away from me, never choosing the point closest to them, and behaving as we'd expect. Looks like good enemy behavior. Now let me show you one thing. Because the grid size is a variable, if I go to my ranged enemy and I change attack radius to, I don't know, 2000 for example, and I compile and save and play again, now look how large the EQS grid is. So because we are generating it based on the attack radius, so now you can see that the enemy is going to find a point that is on the edges of the grid, but a point where they can still see me. So you can see that yeah, they don't pick anything that's blue. They pick only points where they can see me, even if it's just slightly seeing me. All right, so I'm gonna put this back to, whoa, I'm gonna put this back to 600. And one thing I forgot to do in the trace, don't forget in advanced to add a value to context height. So this is the height of the trace, where it's going to go to, because right now it's going to be from the floor to the floor. So let's add something like 100, so it goes to at least the length of the chest of the player, to avoid weird things where the trace collides with I don't know, a small block or box on the floor. All right. Now that we have the enemy moving around, let's have the enemy attacking. We created this cool montage to attack, but we haven't used it yet. So back here in our BP enemy ranged, let's implement our attack function. So the first thing we're going to do is we're going to play montage. Make sure to select this play montage, not play anim montage, but the first one, because this one has all the additional execution pins. Put the skeletal mesh of our enemy, and the montage is our rifle fire montage. And in our rifle fire montage, we have this notify called fire. And when fire happens, this is when we actually want to fire the weapon or do the attack. So back here in my ranged, I'm going to switch on name. When you do a switch, it connects it to here by default. Make sure to connect it to on notify begin. And in the details, I'm going to remove the default pin and add a new one called fire, so that it listens to a notify with the name fire. And then once this happens, I want to actually do a line trace. So I'll do a line trace by channel. And the start location is going to be wherever my weapon is. So I do have a variable for the weapon, this weapon actor. Get actor location, that's going to be the start. And the end is going to be the location of my attack target. So if you recall, the attack target is actually stored here in our AI controller. So from our pawn, we can search for get AI controller. And the controlled actor is just ourself. And we want to cast this to AIC enemy base. Now let's move these here, put our cast here. By the way, there's something called also a pure cast, so I can right click and do pure cast here. And this doesn't need an execution pin, but just to be safe, I'm going to keep the normal cast. And from our AIC enemy base, get our attack target. And make sure it is valid, so convert to a validated get. And if it is valid, I'm going to get the actor location. And that's going to be our end location. So the start location is our weapon location, and our end location is the attack target's location. So we're doing a trace. Let's also draw the debug for a few seconds just to see it in the world. And we're going to check if there is a hit. That means the line hit something before reaching the player. Then it's not an actual hit because there was something in the way, like a wall or something. And only on false do we actually do a hit. So we can print hit target, for example. All right. Yeah, let's, oh, and don't forget that on completed, we want to call this our event dispatcher on attack end. Otherwise, the behavior tree task will keep stuck in an infinite loop. So on completed or on interrupted, we call on attack end. Well, let's play and see what this looks like. So the enemy moves to a location. Oh, we forgot in our behavior tree to add back our default attack. Enemy moves to a location, shoots me, does a line trace. Perfect. By the way, you won't see the print because there's this weird bug where if you use the AI debugger once, then print statements stop showing up. But yeah, I'm pretty confident that this is working. So obviously if I'm behind the wall here, see, now there's a hit. So this is incorrect, or this won't hit the player. And this is the next thing we're going to fix. So I can keep hiding from the enemy because they don't stop what they're doing when they can't see me anymore. He's going to keep doing his sequence, the sequence of moving to a point and firing. He's going to try to move to a point where he can't see me from, but while he's doing that, if I get out of range or if I go to a point where he can't see me, it doesn't interrupt his actions. So we want to change that. We want to say, if at any point you lose sight of me, interrupt what you're doing and go to a place where you can't see me, so that this doesn't ever happen, where the enemy hits through a wall like this. Very unrealistic. So let's do that. How do we actually do that? Well, we need a decorator to tell us if the enemy can see me or not. So just like the trace that we did here in our EQS, we're going to go back to our behavior tree and under decorators, say new decorator from blueprint base, put it in our decorators folder, call it btd underscore can see target. Over on functions, as always, override perform conditional check AI, and let's add a variable, call it attack target key of type blackboard key selector. Make sure to click the eye icon, very important, so we can edit it from the behavior tree. And let's put it in a category called trees, as always. Sorry, keys, not trees. All right, so first thing we need to do is get our attack target. So pull off of the blackboard key and say get value as actor. And now we want to do a trace, the same trace we did. So line trace by channel. The channel is the visibility channel. And the trace starts from the controlled pawn, which is the AI pawn, get actor location. So from the location of the pawn to the location of the attack target. That's the end. And maybe actors to ignore. We want to make an array here to ignore the pawn itself so that we don't accidentally collide with ourselves. You also might want to add the weapon here, but I think I have a collision disabled on the weapon. And if I don't, I probably want to do that. Yeah, so I do have no collision on the weapon, so that's fine. All right, and then we want to return. So if true, that means the trace hit something. So that means that the enemy can't see me because there's something in the way. So we want to invert this. So do a not Boolean, and then that will be our return value. So if there is no hit, then can see target is true. Yeah, I think that's pretty much it. Let's see how we can use it. So back here in our combat state, remember our combat state is a selector. So it's going to select between this or something else. So on this evade and attack, I'm going to add the decorator we just created, can see target. So only if you can see the target, make sure the target key, the attack target set to the right key. So only if you can see the target, do all of this. But what happens if you can't see the target? Well, then we need another sequence to play. So let's say this is called move to line of sight. So if you can't see a target, first thing you want to do is maybe clear the focus. You're not looking at the target anymore. and you want to set the movement speed to something like sprinting, and then move to a location where you can see the target. So what is that location? Well, actually, we can run the same EQS query because we have a trace here to ensure that we do see the target. So I'm just going to run the same EQS query, give it the attack radius, everything else is the same, except the run mode. I'm going to select the single best item. Now I don't want it to be random, I want them to go to the best item where they can see the target from. And after you run the query, always call move to, pass the point of interest, which is the same key that we added here. And actually that's it. So after you move to this location, this Blackboard key variable should switch to true again, and then run this sequence. But very important, what we need to do is click on the Blackboard key, the decorator, and in observer aborts, say both. This means that whenever can see target is changed, if you're in this sequence, abort it. You're only in this sequence if you can't see the target. So if something happens and you're able to see the target again, then just ignore what you're doing and go back to attacking. And if you are currently attacking and can't see target has become false, then ignore the attacking, stop whatever you're doing, and go back to moving. So this is very important because this is what actually interrupts the enemy's AI. So don't forget this one. And the enemy's action, sorry. So let's see what this looks like now. If I go here and I play, so enemy moves around, everything's the same. They're still doing the attack and evade sequence. And if I go out of sight, they ignore what they're doing and move within sight. And they're running now. So there's never going to be a case where the enemy tries to attack me through the wall again, because we interrupt whatever they're doing. Perfect. So if I run away here from the enemy and get out of sight, they're going to clear the focus and try to reach me. And as soon as they reach me, they go back to their attacking and evading state. Very nice. All right, so one other thing I want to do to give this enemy some more behavior and some more, let's say, intelligence, is I want them to react to their own health. Now, I don't think we have health yet, and I'm going to integrate this entire AI tutorial series with our damage system series to have proper health and death effects. But until then, let's just add in our base enemy some simple health mechanics. So over here in our variable, let's add a variable called max health. It's going to be of type float. And let's also add another one called just health, which is our current health of type float as well. And let's give them both a default value of 100. Don't forget the default value, very important. Otherwise they start out dead. And let's maybe add another value variable called isDead, which is a Boolean that starts out with false, of course. All right, so let me close all of this now. Keep this one open, close this, close this. All right. So how do we damage the enemy so to decrease their health? If you recall, if I open up my BP player, at some point we did this in the perception tutorial, we did this report damage event whenever we press X. Now I also, let me just also to visualize it here, I'm gonna spawn an emitter at location, whatever this location is, and I'm gonna spawn this explosion effect, just for you to visualize it. So now if I'm playing and I press X, oh, no, this is the wrong location, sorry. I actually want it to be the location of the enemy, so it's this location. All right, so now if I'm playing and I press X, you'll see that there is an explosion effect happening at the enemy, and we're reporting damage. But we're not actually applying damage. So report damage is just for the AI perception system, but apply damage, that's a different function. So I want to call apply damage here, and this is comes default with the engine. And the actor that's being damaged is this enemy here. And let's say we want to damage them by, I don't know, 20 points or something. And the damage causer is self. Actually, we don't really need it, but I'm just going to do it anyway. All right, so then back here in our enemy base, in our event graph, which is currently empty, right-click and search for event any damage. So this is called whenever this actor is damaged. I'll just make sure I'm compiled here, compile, yeah. So what I want to do here is when I take damage, I want to set my health to be whatever my current health is. So get health minus, subtract from my current health the damage that I just took. And I'm going to clamp it so that it never, so clamp ensures that this value doesn't go beyond the minimum or the maximum. So I'm always going to clamp it at 0, and the maximum will be our get max health. And I'm just going to set that to be our new health and check in a branch if this value is less than or equal 0, then I'm going to set is dead to true. All right, so very basic health mechanics now. We're not going to do anything anything fancy yet, but this is just so that we can decrease the health of the enemy. All right, so back here in our behavior tree, I want to be able to react to the health of the enemy. But we don't actually have a way to get the current health. So let's go back to our, where was it? Our enemies folder, AI, and open up the blueprint interface, so BPI enemy AI. And let's add 2 new functions here to get the current health, which returns health as a float. And I'm just going to duplicate this and say get max health, and it just returns the max health also as a float. Now if we compile back here in our BP enemy base, let's implement these 2 functions. So get max health just returns the max health variable, and get current health just returns the health variable. Or you can also just pull it from here. Same thing. All right, compile and save. Now we can call these functions in our behavior tree. But first we need to create another decorator that checks for if the health is less than a certain value. So what we want to do here, so let me just visualize it for you before I create it. So we have this being the highest priority now. And if we can't see the target, we're going to do this. If we can't see the target, we're going to do that. But now we want something of higher priority here, another sequence node. If we can't, so if our health is lower than a certain value, or if our enemy health is lower than a certain value, I want the enemy to go on hide, take cover. If you recall, we did have this take cover, I think somewhere here. Yeah, so we had this find cover sequence. I'm just going to copy this. Where is my, yeah, in my behavior tree range, then I don't need the attack or the move to ideal range. I don't need any of that. I just need this, the clearing focus, setting movement speed to sprinting, finding cover, and moving to cover. Great. But I only want to do this sequence if my health is less than a certain value. So let's add a decorator here off of blueprint base, put it in our decorators folder, and call it BTD is health below threshold. As always, override the perform conditional check AI, and we're going to add a variable, call it the health threshold. And this is going to be a float value between 0 and 1, so a percentage. So I want to check if my health is below 30%, my health is below 20%. So click on the eye icon, very important. And I can go here in the slider range, say the minimum is 0, the maximum is 1, and same for the value, just to ensure that when you're setting it, you don't put a number that's not between 0 and 1. So what do we need to check here? We actually need to get our max health from our BP enemy AI, and we also need to get our current health and get the percentage of the health. So we need to get the health divided by the max health, and that will give me a number between 0 and 1. And I'm going to check, is this number, which is between 0 and 1, less than or equal our health threshold? If true, then we return true, because the health is less than the threshold. And that's pretty much it for our decorator. Now back here in the enemy ranged, I'm going to call this find cover, and I'm going to add the E is health below threshold decorator. And the threshold value I'm going to put is, I don't know, 30%. So if the enemy health is less than 30%, they're going to stop what they're doing. So to make them stop what they're doing, abort both. So we want to abort whatever we're doing if our health is above 30%, and we want to abort all of this if the health is below 30%. So let's test this out. If I play, the enemy does some stuff. If I damage them 3 times, 1, 2, 3, 4, yeah, and they go run away and hide. Excellent. And then if they see me, they keep running away. Nice. Actually, one thing I also want to do here is after they move to the point of interest, I want them to focus on me again. I'll show you why. So if I damage them 4 times now, because now if they're hiding and I see them, they're always going to be looking at me. So it's good so that they're focusing me when they're hiding, so that even if I go from the left or I go from the right, they're always going to be looking at me. Perfect. Now let's add one more thing. Right now when the enemy hides, they can't do anything anymore, they just stay hiding. Now I want them to go hide and heal, and once their health has reached a certain value or above the threshold, then they come out and attack me again. So let's add a heal functionality in our enemy base. Let's add it in our interface first. Add a function, call it heal, and let's give it a heal percentage, which is a float. And this is going to be also a value between 0 and 1. So in our enemy base, let's implement this heal function. So heal is basically going to set the current health. What did we call it? We just call it health. So set health. So if I say heal by 10%, I want to calculate how much 10% of the maximum health is. So to do that, you just multiply this percentage by your max health, and then it gives you an absolute number. So if I'm multiplying 0.1 by 100, it gives me 10. So I'm going to set the health to be whatever my current health is, plus or add this value to it. All right. And don't forget, we also need to clamp it so that it never exceeds the maximum. So minimum is 0 and maximum is get max health. And that's basically our heal function without any fancy animations or effects right now. It just heals. And also we need to create a task for heal. So in our behavior tree, go to task, say BTT blueprint base, put it in the tasks folder, call it BTT_heal. And as always with tasks, right click, event, receive, execute AI, finish, execute, success true. And all this is going to do is just get the pawn and call heal. Very simple. It's not going to do anything. And maybe the heal percentage, we want this to be a variable. So right click, promote to variable. Yeah, just call it heal percentage, and slider value between 0 and 1, 0 and 1. Compile and save. Great. So back here in the behavior tree, after they find cover, let's have them heal. Did I forget to click the eye icon? Yes. Oh, I forgot to click the eye icon. Now I see heal percentage. So let's have them heal by, I don't know, 5%. So 0.05. And after healing, let's have them wait for 1 second. So they're not healing all the time, they're healing every second. All right, so let's see how this looks like. Oh, no. Okay, yeah. So if I play now, the enemy's doing their thing, they're moving around, they fire. Now if I damage them 4 times, they're gonna run away, hide, heal for a bit, and come out to attack again after they've healed. Perfect. And if I run away where the enemy can't see me, they're going to chase me and go to the point where they can see me. Nice. Let's damage them again. Oh, enemy's hiding, enemy's healing, and enemy healed. Very nice. Now I'm really liking this this smart enemy now. So now let me show you one pretty cool thing. So we do have 2 enemy types now. And if I open my AI folder and in our AI controller, AIC enemy base, we have this handle sensed sight. So what happens when the enemy sees something? And we check that only if the enemy sees the player do they attack. Now I'm gonna disable this just for a second. So I'm going to plug this directly here, and I'm gonna remove this for now. So this means that the enemies can sense any actor, including other enemies. So that means I can take my melee enemy and just have them both attack each other while I sit back here and watch. Nice. Yeah, so now we have 2 enemy AIs fighting each other. Now obviously if we had a damage system and all of that in place, we can see who will actually win. I have my money on the ranged enemy, but it seems to be a close one. So this is pretty cool. So now we have ranged enemies, we have melee enemies, both with different behaviors, different attacks, and so on. And we're going to create a lot more enemies. So we're going to have defensive enemies, mage enemies that can blink and do a whole bunch of things. But before we do that, actually, in the next tutorial, what I want to do is combine the damage system that we created a few tutorials ago with our enemy AI tutorial. What this will allow us to do is to create a full damage system so that we can actually see how the enemy responds to damage, hit reactions, death, and so on. Because incorporating these things also requires some work in our behavior tree to add a state for death, to add a state for hit reactions, and so on. So that's what we're going to be doing in the next tutorial, and it's really going to bring our game to life, because then you can actually see some action. You can actually start fighting your enemy AI. So I hope you enjoyed this, and see you there.